Today, we will be solving an optimization problem where we will be finding the maximum volume of a box made from a cardboard. So, I prepared for you two questions. This is one of them, and we'll do the second one later on. A factory worker wants to construct the top open box from a cartoon formed by a 15 by 7 inches. So, our length is 15 and our width is 7. To do this, the worker plans to cut out 4 squares of equal size from the 4 corners so the sides can bend upwards. What size should the square be in order to create a box with the largest volume? So here, since we're looking for the largest volume, this means optimization. And largest means we need to find the maximum. And to find the maximum, we need to find the first derivative. So maximum means first derivative. Now, this is our cardboard, a 15 by 7. We're cutting 4 equal squares from each corner. So we'll be cutting 4 equal squares from each corner, but we don't know what are the sizes. So we'll take these sizes as x. So we'll have a square cut from each corner, a size x by x. Now, to be able to find the volume, the maximum volume, we need to do an equation. And the equation for the volume is length times width times height. Now, we had a length of 15 inches. We had the length of 15 inches. Our new length would be 15 minus an x from that side and minus an x from that side, because we're cutting an x from each corner to remove the square. So we'll have our length 15 minus 2x. Now for the width, we had our width at 7, and we're removing an x from here and an x from here to be able to bend it up. So we'll have 7 minus 2x. And we have now the height. Whenever we bend our object upwards, our height will be this side, and this side, and this side. So our height will be x. Now, we're almost done with the formula for the volume. We just need to expand. So 105 multiplied by 7 is 105. So 15 multiplied by 7 is 105. 15 times negative 2x is negative 30x. Negative 2x multiplied by 7 is negative 14x. And negative 2x multiplied by negative 2x is positive 4x squared, all into x. Now we combine like terms, which is the negative 30x and negative 14x. We will have negative 44x plus 4x squared, all multiplied by x. And now we need to distribute the x. So we'll have 4x cubed minus 44x squared plus 105x. That's our final volume function. Now, I forgot to mention, whenever we are working with cases like that, we have conditions. For example, x cannot exceed a certain number. So here, whenever we're working with something like that, we look at the smallest number between the length and width. And here the smallest number is 7. So we'll have a condition 7 minus the two x's that we remove should always be greater than 0, because we cannot have a negative length. And now we solve for x. So 7 will be greater than 2x. We divide by 2. Then we'll have x should be less than 7 over 2, which is 3.5. And of course, since x cannot be a negative number, it should be greater than 0. So now our condition is x should be between 0 and 3.5. Greater than 3.5 to will be rejected, and less than 0, it will be rejected as well. Now, to find the maximum or the largest volume, we said we need to find the first derivative. So now we find v prime of x. 4 multiplied by 3 is 12, x squared, minus 44 multiplied by 2 is 88, x plus 105, and we equate it to 0. Now you can use mode 53 on the calculator, and I already got the values, just so that we don't waste time. We'll be having x equal to 35 over 6, which is equal to 5.83. This is x1, and x2 is equal to 1.5, which is equal to 3 over 2. Now, here is the most important part. We'll need to go back to our condition and see which x value satisfies our condition. At x1, we had our x to be 5.83, whereas our x should be between 0 and 3.5. So x1 will be rejected. We cannot use it. Now for x2, we have x2 to be 1.5, which is indeed between 0 and 3.5. So x2 is accepted. Now, we found the x, but we didn't find the volume yet. So to find the maximum volume, we need to find v at 1.5, which means we'll replace instead of each x 1.5. We'll have 4 into 1.5 cubed minus 44 into 1.5 squared plus 105 into 1.5, which will give us 72 inches cubed. Now, why is it inches cubed? We started off by inches and we had at the end inches cubed, because in the volume we multiplied three criteria, which are the length, width, and height. Inch multiplied by inch multiplied by inch gives us inch cubed. So always area is a unit squared and volume is a unit cubed. That's why we have our final answer as inches cubed. And now the maximum volume is 72 inches cubed when x was equal to 1.5 inches, or the square cut was 1.5 by 1.5 inches. That was the first question. Now we'll do another question just with other numbers so that we can practice more. So here it's the same question as we had before. The only difference is that I changed the numbers. Before we had 15 and 7, now we have 30 and 14. So our large size is 30 and our small side is 14. As we said, we are cutting boxes from each corner with a size of x by x to be able to do a box out of it, and we care about the maximum volume that we can get. First thing, we need to find our condition. Condition is our smallest number between these two, which is obviously 14, minus 2x, because we're removing an x from here, and an x from here should be greater than 0. And now we solve for x. We take the negative 2 to that side. We'll have 14 is greater than 2x. Now, we divide by 2, where we'll have 7 should be greater than x, and obviously x should be greater than 0. So our final condition will be x should be between 0 and 7. Now we can start formulating our volume equation. As we said, volume is length multiplied by width multiplied by height. Our length here was 30. And since we're cutting x from each side of it, it now became 30 minus 2x. For the width, it was 14, but since we're cutting an x out of each side, it's now 14 minus 2x. And our height is this part here, which are all x. So our height is x. And now we distribute 30 multiplied by 14 is 420. Negative 2x multiplied by 14 is negative 28x. Negative 2x multiplied by 30 is negative 60x. And negative 2x multiplied by negative 2x is positive 4x squared, all multiplied by x. Now by combining like terms, we have 420 minus 88x plus 4x squared multiplied by x. So our final x equation will be, by distributing the x's, we'll have 4x cubed minus 88x squared plus 420x. This will be our v of x. Now to find the maximum, as we said, we'll need to find v prime of x, and we'll equate it equal to 0. So v prime is 4 times 3 is 12x squared. Negative 88x squared will become negative 176x plus 420 equal to 0. Using mode 5.3 on the calculator, we get x1 to be 35 over 3, which is 11.6 inches, and x2 to be 3. Now, we have these two numbers. We need to check whether they are in our condition or not, if they are accepted or rejected. 11.6 inches is greater than 7, so x1 is rejected. x2 is indeed between 0 and 7, so our value here is accepted. To find the maximum volume, we just need to replace this x into the volume equation. So 4 into 3 cubed minus 88 into 3 squared plus 420 into 3, which will give us 4 into 27 minus 88 into 9 plus 420 into 3, which is equal to 576, and as we mentioned, inches cubed, because we multiplied length and width and height. So maximum volume is 576 inches cubed when our x value is 3 inches, or whenever we cut a 3 by 3 square from each corner.